In this video, we're gonna go over definite integrals, and this is the last topic for chapter 6. So suppose you have the graph of a function, f of x, and you want to find the area under this curve, right? So suppose you want to find the area under this curve. You start from A, and you go to B. So you want to find the area of this yellow part. And using what you know right now, how would you do it? That is the question. Alright, so one way to do this, one way to estimate the area, and remember, previously when we discussed derivatives, we estimated the slope by using a secant line, right? And then we decrease the distance. So we'll do something similar here. So to find the area, rather than, because I don't have any method to find it accurately, I can find an estimate. And to find an estimate, what I will do is I will draw a rectangle like this. And I will draw, so the rectangle will touch the graph, right? Y is equal to f of x. And it will be something like this. So it will be, if you draw rectangles like this, you'll get an underestimate, right? So your area is the area of the rectangles. If you add all the area of the rectangles together, that is going to be smaller than the actual area under the curve, but we are willing to work with that. So we have something like this. So I'm so sorry that my rectangles look very, very bad. I'm trying to draw them straight, but the software isn't registering the stylus for some reason. All right, something like this, right? So let's say that each width of the rectangle is this del x, right? Triangle x means change in x. That is the width. And assuming all rectangles have the same width, right? So we will say that area of the pink region that we have made using the rectangles is going to be our area under the curve. And you can see it's not exactly the area under the curve, is it? It's slightly less because there's some area here that we have not considered, but that is fine. So we are saying that to approximate the area under the curve, we are adding the area of all the rectangles, right? So when we say we want to add things together, we will use something called the sigma notation. So sigma just means add together the area of the rectangles. Now, what is the area of one rectangle? That is the question, right? The area of one rectangle, well, it has the width delta x. That is the width times the height will give me the area, right? What is the height? Well, the height is just f of x at this value, right? At the left endpoint. At these values, that is what f of x is. So the height is f of x evaluated at this x and this x and this x. All right. So we will represent that as f x I, right? So basically, how we will define this is that xi is going to be a plus I delta x. So you start from a, right? If I is 0, so x0 is just a. So you start from a, this is x0, and then if you want to go to x1, which is this one, that is going to be a plus delta x. And that makes sense. 1 times delta x is just delta x. And that makes sense because you have to move delta x width here. And if you move 2 delta x width, you get to x2, and so on. So we will use this definition for xi. And now, since we're finding this area from A to B, so you need to go from I is equal to 0 up until n minus 1. Let's say we have, and this is assuming you have n rectangles of equal widths delta x. And what is delta x? Well, delta x is going to be b minus a, which is this width, right? And then divided by the n intervals that you have. So all of these together. So now let's, before we go on, what does this mean? Well, this just means f(x0) delta x plus f(x1), right? So you substitute 0 here, and then sigma just means plus. So f(x1) delta x plus f(x2) delta x. So you start from I0, you substitute 0 wherever your I is, delta x. So this is just I just substituted I0 here, plus, and then you move on to 1, I1, I2, and then you do it on and on up until you get to I is equal to n minus 1 dx. So that is just what this means. And if you think about it with reference to this diagram, you're going to see that this is the area of the first rectangle, this is the area of the second rectangle, this is the area of the third rectangle, and so on and so on. And this is going to be the area of the nth rectangle. All right, so now that we have this down, another way to represent this is the same thing here. This one is that if we change the index, so rather than starting from 0 to n minus 1, we can start from 1 and go up till n, and instead of I, we will have I minus 1 delta x, and this is also okay. So it's the same expression, and we won't really go into details because this is not necessary. Just hopefully this gives you an intuitive understanding. So if you substitute 1 here, you will get this expression. If you substitute 2 here, you'll get this expression into this new formula. If you substitute 3, you will get this, and if you substitute n, you will get this. So it's going to be the same expression, just I've changed the index a bit. And the idea is that, hey, if my rectangles are smaller and smaller, the smaller rectangles I take, the more accurately I'm going to be able to cover the area, right? Because these big rectangles were leaving some space out. So you had space here and here, right? So the big rectangles were leaving some space out. So let me just highlight that very quickly. So the space in red, right? The one that I'm highlighting now, that's not being covered by my rectangles, but that is still the area under the curve. So if I take smaller and smaller rectangles, I'm going to get better at covering those areas. And the idea is that if my rectangles are infinitely small width, right? So if my rectangles are of infinitely small width, that means dx is width. So dx tends to 0. And this happens if my n is very, very big. If I take lots and lots of rectangles. So if n tends to infinity, then my width becomes smaller and smaller. So I need to take many, many, many rectangles of infinitely small widths. So the idea is that if I take limit as n tends to infinity of this expression, sigma I is equal to 1 n f of xi minus 1 dx, that is going to be the area under the curve. And that is going to be equal to the definite integral from a to b. So this is sort of ties into the definition of the definite integral from a to b of f of x dx. So this dx is just this width, but it's an infinitely small width, and we are taking f of x to be the height at every point. And that is it. So I know the explanation may not have made sense, but I'll show you how to do the integration so that for your exam you don't need to know how the expressions and everything came about. You just need to know how to solve this expression. But I just wanted to tell you that doing this is to find the area under the curve from A to B. Area under the curve from A to B. That is what we were doing. We were doing area under the curve from A to B. So yeah, this expression, whatever we are going to do in this topic, we are actually finding the area under the curve from A to B. All right. With that said, let's do some questions. So if you remember, when we integrated a function with respect to dx, we got another function, capital F of x, plus some constant, right? So if we integrate a function from a to b, This is definite integral. Now there is no constant of integration, but rather that is going to be your big function. And we know how to find this big function. Evaluated at b minus this big function evaluated at a. And we know how to do this. And all the rules of integration still hold. So for example, if you are doing integrating this expression, then you can just do it separately. So this formula that we did for indefinite integrals is still valid, but now you have to do it with the bounds. And the integral from a to b of k times f of x dx is k integral from a to b f of x dx. So now, instead of just integrating, you also have the bounds. And one final rule that we probably won't be using, but it's still helpful to know, is that if you're integrating from a to some value c, right, f of x dx, then it's the same as you can integrate from a to b, and then you can integrate from b to c, where b is within the open interval a and c. So if b lies between a and c, right, then integrating from a to c, you can just pick any b in between a and c, and you can first integrate from a to b f of x dx, and then you can integrate from b to c. And this is assuming that the function is continuous in this interval. And finally, if you integrate from a to b f of x dx, if you switch the bounds, then you have to put a negative sign in front. So integrating from a to b is the same as negative of integrating from b to a. So if you switch the bounds, this is called the lower bound, this is called the upper bound. So if you switch your lower bound and your upper bound, you need to put a negative sign in front, f of x dx. And that is about all the rules that we have. And we probably aren't going to use most of these, at least for this topic, but very helpful to know. And we will definitely be using this when we get to the grade 12 part. So this is going to be the most important formula for at least the grade 11 section, but we are going to use all of these when we get to grade 12. All right. So I hope I can erase this. And now we can start doing some questions. Alright, so I'm not gonna do all of them like always. I'm gonna skip some. So I'm gonna do the ones I highlighted, and I hope that you are able to do the ones on your own that I have not. Okay, so part B. We are integrating from 1 to 3, 4 over x cubed dx, right? Alright, so I can write this as 1 over 3. You can always bring your constant out, whether it's definite or indefinite integration. And you have x to the power negative 3 dx. And we know how to integrate this. So what we are going to do is just integrate it. So you put these sort of curly brackets and you integrate your function inside. So if I integrate this, it's going to be x to the power negative 2 divided by negative 2. Right? And I don't need to write plus c because this is definite integration. So this is my f. And now I need to evaluate my solution to the integration at 1 and 3. So I'm going to write it this way. Right? This was my lower bound here, my upper bound here. So this is what I got. Now I can always pull out the constant. So if I pull out negative 2 outside, I have 4 divided by negative 2. And that gives me just negative 2. And inside I have x to the power negative 2, which is 1 over x squared. And I have my bounds 1 and 3. So integrated normally. Once you integrate it, you don't need plus c. You just write it here, and then you put it inside these big brackets, and then you just put your bounds on your right hand side like this. 1 and 3. All right. So now you just substitute 3 into this equation, and then 1 there. So you substitute 3 here. What do you get? You get 1 over 3 squared is 9. Minus, You substitute 1 here, you get 1. So you have negative 2. 1 over 9 minus 1 is going to be negative 8 over 9. And if you solve this, you are going to get 16 over 9 as your solution. So that is the solution for B. I hope that was clear. And once we do more questions, I think things will be clear. But now I need to go back and check if I gave you the correct formula. So let me just go back, because I feel like I messed up somewhere. Now, the question 16 over 9 is the correct answer, but when I was giving you all the formulas at the start, I feel like I may have given you something wrong. Okay, no. Okay, it is f of b. So we substituted 3, and then minus, we substituted 1, right? 1 was our lower bound, 3 was our upper bound. So I gave you the correct formula. Okay, I'm so sorry about that. So let me erase everything again. And we are done with b. So let's do d. So d is 10 minus x squared dx. So integration of 0 to 3, 10 minus x squared dx. All right, fairly simple question. I know how to integrate this, right? Do your indefinite integration first, just don't write plus c. So if I integrate this, and I'm going to leave the integration to you, but I think you should be familiar with how to integrate this expression by now. Integration of 10 with respect to dx is just 10x, right? You copy your sign, minus. Integration of x squared with respect to dx is 1 over 3 x cubed, right? You raise your power by 1, you divide by your new power. And now you substitute your bounds. Your lower bound is 0, your upper bound is 3. So you do your indefinite integration, do it manually. You will see that your answer is this plus c. Do not write plus c, just write this inside these square brackets, and then you substitute your lower bound and your upper bound. Now substitute 3 into this equation. What do you get? 10 times 3 is 30, minus 3 cubed is 27 by 3 is 9. After you substitute 3, write your negative sign and substitute 0 here. You substituted 3. This is what happens when you substitute 3. You copy this. So you substitute 3 here. You get this. And then the formula has a negative sign. So you just put your minus sign and then you substitute 0. All right. So now if you substitute 0 here, you will get 0. So your answer is going to be 21. That is your solution to D. All right. And F is going to be very, very similar. F is going to be the integral from 2 to 4 of 2 minus 6 over x squared dx. All right. So let's integrate this. And I'm going to do it very quickly. If you integrate it, you're going to get integration of 2 dx is 2x. You copy your minus sign, and then you have integration, right? Integration of 6 times x to the power negative 2 dx, right? If you integrate this portion. All right. And if you integrate this, you are going to get x to the power negative 1 divided by negative 1. You raise your power. Negative 2 plus 1 is negative 1, divided by negative 1. And then you need to substitute your bounds. So if you do your indefinite integration, you get this plus c. Do not write plus c. And then you put this inside square brackets. You substitute 2 and 4. All right, now let's simplify what we have inside. We have 2x plus 6 over x. And we need to substitute 2 and 4. First, substitute 4 here. If you substitute 4, you get 8 plus 6 over 4. And 6 over 4 is just 3 over 2. Minus, substitute 2 inside. 4 plus 6 over 2 is just 3. So 8 plus 3 over 2 minus 4 plus 3 is just going to be 7. So 8 plus 3 over 2 minus 7. 8 minus 7 is just 1 plus 3 over 2. Right? And that is going to be 5 over 2. 5 over 2 is going to be your solution. And we are done. So I hope the explanation was understandable, and we are done with question 1. So question 2 is very similar as well. A, I have the integral from 1 to 2 of 3x squared minus 2 plus 1 over x squared dx. All right. Let's let me do it manually, right? Let me just find the integration of this expression. And that is going to be, I first integrate like this. Right? I separate it into parts and I integrate them individually. I can factor out my constants. So I can write it like this, and now I can finally integrate. So it's going to be 3 times x cubed by 3, right? You raise your power by 1 and you divide by your new power, minus 2x. Integration of dx is just going to give you x. If you add many, many small dx's together, you're going to get x. Plus x to the power negative 1 divided by negative 1. And because we're doing definite integration here, we are not going to write plus c for now. So 3 and 3 will cancel out, give me x to the power x cubed minus 2x, and this is going to give me minus 1 over x. So this is what happens when I integrate. So now it's just going to be, after I integrate, I just need to substitute in my bounds. So from 1 to 2, right? I first manually integrate. I don't write plus c. I put whatever the solution I get after I integrate into the square brackets, and then I need to substitute my upper and lower bound. So if I substitute 2 here, I get 8 minus 4, right? 2 cubed is 8, minus 4, minus 1 over 2. And then I put my minus sign. This minus sign comes from the formula. Remember, FB minus FA. So B was 2, A is 1. So substitute 1 here, and you get 1 minus 2 minus 1. All right. And now if you simplify this, 8 minus 4 is 4 minus half. It's going to give you 7 over 2. Minus 1 minus 2 minus 1 is going to be minus 2. So your final solution is going to be 7 over 2 plus 2. And that is going to be 11 by 2. And that is your solution to 2a. All right. And we are done. So this is another way. You do your indefinite integration the way we learned slowly first. You then put it inside your square bracket and you substitute in the bounds. That is also okay. All right. So we're done with a. Let's do c. All right. So c is the integral from 1 to 2 of x plus 3, 7 minus 2x dx. All right. We can expand this out. So integration from 1 to 2, we have 7x. So let's write our x squared term first. So if you expand it out, you're going to get negative 2x squared plus 7x minus 6x, right? So plus x plus 21. That is going to be the expression you get if you expand it out. So you have plus 7x minus 6x. So that gives you plus x. All right. And now let's integrate this. And I am pretty sure we have done enough examples that you know how to integrate this. So if you integrate it, you are going to get negative 2 over 3x cubed plus half x squared plus 21x. 21 dx, the integral will give me 21x. Integration of x is going to be x squared divided by 2. And you factor negative 2 out first. Integration of x squared is going to be x cubed divided by 3. And then when you put it together, you get this expression. And then you integrate from, you substitute in your bounds, 1 to 2. So substitute 2 in first. You get negative 2 over 3, 2 cubed is 8, plus 1 over 2, 2 squared is 4, plus 21 times 2 is 42. Minus comes from the formula, and then you substitute 1 here. So you get negative 2 over 3, plus 1 over 2, plus 21. All right, so simplify this. So you are going to get negative 16 over 3 plus 4 over 2 is just 2 plus 42 minus, here you are going to get, let's see, Negative 2 over 3 plus 1 over 2. That is not easy to calculate out, but I think you can use your calculator here, to be honest. Where did I keep mine? Okay, it's here. So I'm going to use my calculator because I'm a bit lazy, but you can feel free to simplify your fractions, and I believe you should be knowing how to simplify this expression. So I'm just going to use my calculator. Negative 16 by 3 plus 2 plus 42. So this part will simplify to 116 divided by 3 minus, let me simplify this part. So you get negative 2 over 3 plus 1 over 2 plus 21. So that is 125 over 6. And if you take the difference, if you solve for your final solution, you're going to get 107 over 6. So yeah, that is your final answer. So I just used my calculator to solve this. But yeah, I think you should be able to use. And I believe there are FX100 calculators that can convert decimals to fractions quite easily. So please use those. And your final answer is going to be 107 by 6. All right. Yeah, part E. Sorry about that. So you're integrating from 1 to 2. 3 minus x times 8 plus x divided by x to the power 4 dx. So now you just expand your numerator out. And if you expand your numerator out, you are going to get negative x squared plus 3x minus 8x. So that is going to be minus 5x plus 24. So if you expand your numerator out, you're going to get this expression divided by x to the power 4. And you can write it as negative x to the power negative 2 minus 5x to the power minus 3 plus 24x to the power negative 4 dx. So I'm going to leave you to figure out how I got to this point, but it's pretty straightforward. And now I can integrate it, and I'm going to leave you, because we have done so many questions like these, but it's going to be negative x to the power negative 1 by negative 1 minus 5 x to the power negative 2 divided by negative 2 plus 24 x to the power negative 3 divided by negative 3 if I integrate everything. And I still need to substitute 1 to 2. And now let's simplify. This negative gives me a positive. I'm going to get 1 over x. Minus 5 divided by minus 2 is going to be plus 5 over 2x squared, because x to the power negative 2 is just 1 over x squared. And then I'm going to get 24 by negative 3. That is negative 8 divided by x cubed. So if you simplify everything, you get this expression. And now I just need to substitute in 2. What happens when I substitute 2? I have half plus 5 over 2 times 2 squared is 4. So 5 over 8 minus 8 over 8, right? 2 cubed is 8. Minus, I substitute 1 in. I get 1 plus 5 over 2 minus 8. All right. And now if you solve for this, if you use your calculator or if you take the time to solve it, which I am not going to because I am too lazy. So this part gives you 1 over 8, and this part gives you negative 9 over 2. And if you simplify, if you put them together, if you simplify, you are going to get 37 by 8. That is your final answer. And we are done with part E. 37 by 8 is going to be your final answer, and I hope it's clear because I don't want to do the arithmetic. And that is it. Question 3 is the same thing, right? Now we are just dealing with fractions. The B is the integration from 0 to 4 of square root of 2x plus 1 dx. So now just take the indefinite integral. So that is just 2x plus 1 to the power half, right? With respect to dx. So if you are trying to take the indefinite integral, what do? Well, you take 2x plus 1, you raise your power by 1. So half plus 1 is 3 by 2. You divide by your new power, which is 3 by 2. But remember, you also have to divide by the number that multiplies x. So that is 2. So you can multiply by half with 1 over 2, or you can just write your division sign by 2. Both are okay. But I prefer to multiply by 1 over 2. So that is going to be your indefinite integral, and I am not going to be writing plus c. But if you simplify, you are going to get this expression, and these 2's are going to cancel out. So your final solution for your indefinite integral should look like this, without a plus c. And now, this is just going to be your final solution to your indefinite integral, which is this, and I can factor out all my constants always. Well, not always, but in this case, I can factor out 1 over 3, 2x plus 1. I have 2x plus 1 to the power 3 over 2. So if you keep this inside and substitute, that is also okay, or you can factor it out. That is also okay. So you put 0 to 4. So you can write 1 over 3 inside and substitute as well. So substitute in 4, which is your upper bound. What do you get? You get 1 over 3. You get 9 here, right? 2 times 4 is 8 plus 1 is 9 to the power 3 over 2. And 9 to the power 3 over 2, we have looked at this value again and again. That is just 27. And minus, you substitute 0 here. You have 1 over 3. 2 times 0 is 0 plus 1 is 1 to the power 3 over 2. So 1 over 3 times 27 is just 9. And from this part, you get 1 over 3. And that is going to give you 26 over 27. That is your solution. No. I think it is, yeah, actually. Sorry, not 26 over 27, 26 over 3. 26 over 3. That is your solution. Because 9 minus 1 over 3, because 9 is just 27 over 3. So 27 minus 1 is 26 over 3. That is your solution to B. And now let's do D. It's just as straightforward. You are integrating from -1 to 1 the expression 6 divided by x minus 2 squared dx. Alright. And we know how to do this. Let's just do the indefinite integral first. You take out 6, you write it like this, right? And then you do 6x minus 2 to the power -1 divided by -1. And you need to also divide by your number that multiplies x, right? So you need to divide by 1, which is the same as doing nothing, right? Whatever divided by 1 is just the whatever you had. So now you have -6 divided by x minus 2. That is your final solution if you do the indefinite integral. So that is just what you do. You put your solution to your indefinite integral, and you substitute in your bounds. Your bounds were -1 and 1. So substitute 1 into this expression. What do you get? If you substitute 1, 1 minus 2 is going to give you -1. -6 divided by -1 is going to give you +6. Minus, you substitute -1 here. -1 minus 2 is going to give you -3. 6 divided by -3 is -2, and minus of -2 is going to give you +2. So your final answer is going to come out as 4. And that is it. That is the solution. So I hope the substitution was clear. And now we are going to do F. So just do your indefinite integration first. 5 minus 2x to the power -12. This is the expression that we have, right? We can always write it like this. And once we have written it that way, what we can do is we can do 4 times, if you integrate this expression, what do you get? You get 5 minus 2x to the power +12, because -12 plus 1 is +12. You divide by your new power, but you also need to divide by the number that multiplies your x. So you need to divide by -2, or you need to multiply by 1 over -2. And I will not write plus c because we are going to substitute bounds later. So 4 divided by -2, that is going to be -2. Actually, this will cancel out, and you will get a -4 in front. You have 5 minus 2x to the power half. And basically, you just need to first integrate. We have done that. We just now need to substitute our bounds. So lower bound is -2, upper bound is 2. Substitute 2 in first. -4, 5, 2 2s are 4, right? So 1 square root of 1. That is just going to be 1. So you just have -4 left. Minus, substitute -2 here. You get -4, you get 9 inside here, and you get to the power half. And square root of 9 is just going to be 3. So you are going to get -4 plus 12, and that is going to be positive 8. And that is going to be our answer. For 3f is positive 8. All right, and we are done. Most of these other questions we are going to do in very similar ways, right? So question 4, 5, and 6 are very similar to the questions that we were discussing in the last video. So given that we have this expression, y is equal to 2x squared plus 5, we need to find dy by dx. So find dy by dx. If you differentiate this, so they are just asking you to differentiate this. So d by dx of 2 over x squared plus 5. So that is the same as 2d by dx of x squared plus 5 to the power -1, right? I hope this step is clear. And now you bring your -1 to the front, x squared plus 5 to the power -2. You bring your power to the front, you decrease your power by 1. But ani x tega made, so you need to differentiate it again. And yeah, if you differentiate this, you are going to get 2x. And I leave you to figure that out on your own. But your final answer is going to look like -4x divided by x squared plus 5 squared. All right, so that is your solution. And it says, hence, evaluate this expression. All right, so what do we know? We know that the integration of -4x divided by x squared plus 5 squared dx is, if I integrate my solution, I get what I started with, right? So I get this expression. I won't write plus c for now. So I can factor out on -4, x over x squared plus 5 squared dx is going to look like this. And if I divide by -4 on both sides, I am going to get, so I divided by -4, I need to divide by -4, right? So if I divide by -4, I'm going to get something like this. This will cancel out, and if I divide by -4 on my right hand side, I get an expression that looks like this. But I need to find if I have 2x in my numerator. So if I multiply by 2 here, I need to multiply by 2 on this side as well. And these will cancel out. So the indefinite integral of 2x over x squared plus 5 squared dx is just -1 over x squared plus 5. And we need to find the integration from 0 to 2. So it's just going to be this solution evaluated from 0 to 2. So now substitute 2 here. You get -1 over 9 minus substitute 0 in here, and you get -1 over 5. So your final solution is -1 over 9 plus 1 over 5. And when you simplify, you get your final solution to be 4 over 45. That is your solution. 4 over 45 is your solution to B. And we are done with question 4. So yeah, 4 over 45. All right. And question 5 and 6 is very, very similar, right? So first question part asks you to find du by dx of x cubed minus 2 to the power 5. So just find the derivative. You bring your 5 to the front, x cubed minus 2. You decrease your power by 1, but ani x tega made, so you need to differentiate it again. And if you differentiate this, you're going to get 3x squared. And if you simplify everything together, you get 15x squared x cubed minus 2 to the power 4. And if I integrate 15 x squared x cubed minus 2 to the power 4 with respect to dx, I get what I started with, which is this expression. X cubed minus 2 to the power 5. What is the question looking for? Well, I don't have any 15 here. I just need to find the integration of this. So the integral of indefinite integral is going to be 1 over 15. And usually we have plus c, but because part B has a bound, so we are just going to be substituting the bounds. So if I need to integrate from 0 to 1, so I divided by 15 on both sides. I hope that was clear. Then I just need to evaluate my solution at 0 to 1. And now substitute 1 into this expression. I get 1 over 15. 1 cubed minus 2 is negative 1 to the power 5 is just negative 1. Minus, substitute 0 here. And you get 1 over 15 times negative 32. And if you solve everything, you should get 31 by 15. That is going to be your final solution. Let's see. I think I made a mistake. Yeah, this is correct, I think, yeah. Because this, you can write it as 2 1 over 15, right? Yeah. So this is correct. All right. So we're done with question 5. And question 6, you want to do it in almost the same way. So let me erase everything. And hopefully we can get question 6 done with. And that is going to be the end of this topic and this chapter as well. So 6a, we are given y is equal to 1 over 10 square root of x plus 1 to the power of 5. So find dy by dx just means differentiate. So 1 over 10 is a constant. I can just differentiate square root of x plus 1 to the power of 5. And if you differentiate that, you're going to get 5 comes to the front, square root of x plus 1 to the power of 4, right? 5 minus 1 is 4. But ani x dega made, so you need to differentiate it again. And if you differentiate square root plus 1 means a constant, derivative of a constant is 0. I don't have to worry about that. D by dx is square root of x. Well, I give you a formula for that, and that is 1 over 2 square root of x. Derivative of the square root of x is 1 over 2 square root of x. And if you simplify everything, you are going to get this expression, x square root of x plus 1 to the power of 4 divided by 4 square root of x. So I know that if I integrate this expression, which is 1 over 4, x plus 1 to the power of 4, x dx, I am going to get what I started with, which was this expression, right? Alright. So now I don't have 1 over 4 here. I just need to multiply by 4 on both sides so that this cancels out. So I get 4 over 10 is just 2 over 5, right? And now I need to do the indefinite integral from 1 to 4. So 1 to 4 just means I need to evaluate this at 1 to 4, from 1 to 4. So substitute 4 in. You get 2 over 5 times 3 to the power 5, right? So you get 2 over 5 times 243 minus, you substitute 1 here, 2 over 5 times 32. So you have 2 over 5 times 243 minus 32. And your final solution as a fraction is going to be 422 by 5. Which also, so if you write everything as a fraction, is going to give you 422 over 5. So you can also write it as 80, sorry, and this is equivalent to 84 times 2 over 5. That is also the same answer. And we are done with this topic. All right. I hope this was helpful. I hope the explanation was clear. I'm sorry if it wasn't, but I hope you'll find this video helpful. All right.